Hey there guys, welcome to my channel. Today we're going to be solving a special equation with radicals and with a strange and special method to solve. So we have 3 plus the square root of 3 plus root x equals x. And obviously we want to solve for x values. Now to do that, I'm going to replace 3 with t. And then I rewrite our equation. So we will have t plus the square root of t plus root x equals x. Next, let's go ahead and subtract t from both sides to get the square root of t plus root x equals x minus t. Next, let's go ahead and square both sides to get rid of the square on the left-hand side. So we will have t plus root x equals x squared minus 2x times t plus t squared. Next, let's go ahead and move everything to the same side. So I can say that we have t squared minus 2xt minus t plus x squared minus the square root of x equals 0. Now, what I want to do here is to write a quadratic equation in terms of t. To do that, I'm going to go ahead and factor out negative t out of these two. So we will have t squared minus the quantity 2x plus 1 times t plus x squared minus the square root of x equals 0. Now, if we consider this equation a quadratic equation in terms of t, we can see that the leading coefficient is 1, the coefficient of t is this, and the constant term is x squared minus the square root of x. Great. Now, using all of that, let's go ahead and apply the quadratic formula for t. So we will have t equals negative b, which is going to be 2x plus 1, plus or minus the square root of b squared, which is going to be 4x squared plus 4x plus 1, minus 4 times 1 times the constant term. That is going to be negative 4x squared plus 4 times the square root of x. And everything is divided by 2. Great. Let's simplify this. So t is going to be 2x plus 1 plus or minus the square root of 4x plus 4 times the square root of x plus 1. And this is divided by 2. Now, here's an interesting thing. This expression, 4x plus 4 times the square root of x plus 1, is a perfect square. It is equal to the quantity 2 times the square root of x plus 1 all squared, right? So because of that, I can get rid of the radical and write t is equal to 2x plus 1 plus or minus the quantity 2 times root x plus 1 all divided by 2. Now we have two scenarios. Either t equals 2x plus 1 plus 2 times the square root of x plus 1 all divided by 2, which means that it is equal to x plus root x plus 1, or t is going to be 2x plus 1 minus 2 times the square root of x minus 1 all divided by 2, which means that we will have x minus root x. Now remember that t is equal to 3, so if I replace t with 3, we're going to have two simple radical equations in terms of x. So we will have 3 equals x plus root x plus 1, and we will have 3 equals x minus root x. So let's go ahead and try to solve these two equations for x. So in the first one, we have x plus root x equals 2. To solve this for x, I'm going to go ahead and replace root x with something like y. Therefore, x is going to be y squared, and we will have a quadratic equation. We will have y squared plus y minus 2 equals 0. And from this, we can say that y is equal to 1, or it is equal to negative 2. But remember that y is the square root of x, therefore y is positive, therefore it is not negative, and this is not valid. So the only valid solution for y is y equals 1. And from that, we can say that the square root of x equals 1, which means that x is 1. But remember that the original equation was 3 plus the square root of 3 plus root x equals x. If you replace x with 1, we're going to get 3 plus the square root of 3 plus 1 equals 1, which is something impossible. Therefore, x equals 1 is not a valid solution, and we don't get any valid solution from the first equation. So let's go ahead and take a look at the second equation, which is this one. So in the second equation, we have x minus the square root of x equals 3. Again, I'm going to go ahead and replace the square root of x with y. So this is going to be y squared, and we will have y squared minus y minus 3 equals 0. So if you use the quadratic formula, we're going to get y equals 1 plus or minus the square root of 1 plus 12 divided by 2. So y is 1 plus or minus root 13 divided by 2. Now again, remember that y is the square root of x, therefore it is positive. So 1 minus root 13 divided by 2 is not positive, therefore it is not valid. And that means that we have only one valid solution, and that is going to be 1 plus root 13 divided by 2. Since y is root x, we can say that the square root of x is 1 plus root 13 divided by 2. That means that x is going to be 13 plus 1 plus 2 times root 13 divided by 2 squared, which is going to be 4. That means that x is going to be 7 plus root 13 divided by 2. Cool. Now, in order to validate this, let's go ahead and take a look at the original equation and plug it in the original equation and see if it satisfies the equation or not. So the original equation was 3 plus the square root of 3 plus root x equals x. Now remember that the square root of x is this and x is this, so let's go ahead and plug these two values in. If we do that, we're going to have 3 plus the square root of 3 plus 1 plus root 13 divided by 2 equals 7 plus root 13 divided by 2. Cool. Now let's go ahead and simplify the left-hand side. So we will have 3 plus the square root of 2 in the bottom and 7 plus root 13 on the top. And to simplify the left-hand side even more, let's go ahead and multiply this fraction both on the top and the bottom by 2. So we're going to have 3 plus the square root of 14 plus 2 times the square root of 13 divided by 4. Now, notice that this expression is a perfect square. We can write it as 1 plus root 13 divided by 2 all squared. So because of that, we can get rid of the radical and write the left-hand side as 3 plus 1 plus root 13 divided by 2. And then we need to get a common denominator. So we're going to have 2 in the bottom and 7 plus root 13 on the top. That means that our solution is a valid solution because this is a true statement. Great, so we have only one solution for x, and that is 7 plus root 13 all divided by 2. And this brings us to the end of this interesting and special video. Thank you for watching this video. Please consider subscribing for more contents like this, and hit the like button if you enjoyed watching this. Hopefully I will see you later. Goodbye for now.